Today we're going to look at the composition of functions. What a composition is you have two functions. I'm taking the first one, I'm picking it up and I'm putting it inside the second one and making like a super function. It's kind of like system of equations dealing with the substitution method, sort of that kind. And we've got our three functions, f of x, g of x, h of x. Now let's combine them. I guess before we combine, let's understand what's happening here. This is f little circle g of x. What that little circle means, it means of. So it's saying, it's read f of g of x. It's not multiplication, it's like an of symbol. So I'm going to make this a little easier to understand. I want to rewrite this. I like to rewrite it and say f of g of x. So this helps show me that I'm taking my g function and I'm going to put it inside the f function. So I'm taking my g problem, I'm going to put it inside my f, and the only place I can put it is right there where that x is. So let's rewrite. We've got, we'll take our gx, 3x plus 1. This whole thing goes inside. That whole thing goes inside this little group right there. So put that 5 in front. We've got 5 times the group, 5 times that group. Now let's just simplify it. Distribute 5 and 3x gives us 15x. 5 and 1 gives us 5. And bring down the composition. You can go back to the beginning. All right. With multiplication, if we change the order, we ended up with the same answer. Does that happen with a composition? Well, let's find out. So here, get rid of some of all this. I have f and g again. I want to rewrite that in a way that I can understand it. So g of f of x. So what you see at the end is always going to be on the inside. I'm going to take my f problem and put it inside my g. I'm taking my f and I'm going to put it inside my g problem. The only place I can put it is right there. So we're going to rewrite this and say 3 something, and what's that something? Turns to that 5x, and then we bring that 1 at the end. Okay, so let's multiply. The only thing we can multiply here is 3 and 5, so give us 15x, and then that 1 comes down for the ride. Answers are close, but no, they do not come up with the same answer when you reverse them. So let's bring down that composition, g of f of x. Good. And now we're looking at g and h. So we'll get rid of all of that. So g and h, I want to rewrite so I can understand this. G of h of x. H comes second. That's what goes on the inside. So I'm now taking my h problem, picking it up, and I'm going to put it inside my g. The only place I can put it is in place of that x right there. So let's rewrite. 3, what goes on the inside? X squared plus 2, and then you get that plus 1 at the end. Now, let's distribute and combine like terms. 3 and x squared gives us 3x squared. 3 and 2 gives us 6. Bring down that 1. And the only thing we can combine is that 6 and 1 to give us 7. Bring down the composite. And there you go. I guess really the one last thing to find would be what's your domain of everything. What numbers are we allowed to plug in for x? So my domain, I can plug in here. I could say 15 times a positive. I could say 15 times a negative. I could say 15 times 0. I could say 15 times a fraction or a decimal. There's no restrictions. There's no ending to what I can do. So all real numbers. Same thing here. The only difference is that 1. But again, our answer, all real numbers. Does it change when you have an exponent of 2? Nope. Again, I can plug in any number I want, no problem. All real numbers. The only time you have a problem is when your answer is a fraction and you've got something on the bottom. And that is finding the composition of functions.